Good morning, students. We'll do some problems in the wave optics. Already synopsis I explained. Do the problems. See, the phenomenon of interference is shown by longitudinal mechanical waves only, transverse mechanical waves only, electromagnetic waves only, all the above. So either longitudinal mechanical or transverse mechanical or electromagnetic waves, whatever they may be, all will show interference. So option for this will be fourth option. Okay. Next, by Huygens wave theory, we cannot explain the phenomenon of interference, diffraction, polarization. See, interference and diffraction, they will be explained by any theories. But polarization only explained by Huygens theory. So, except photoelectric Max Planck's quantum theory, basing on that photoelectric effect will be explained. So remaining this Huygens wave theory will not explain the photoelectric effect, either interference or diffraction or polarization. Those will be explained by Huygens wave theory. Photoelectric effect is explained by Planck's quantum theory. Next, in an interference experiment, ratio of intensities of bright band and dark band. So I1 by I2 is equal to 16 by 1. Then they are asking what is the ratio of the amplitudes. I1 means bright band intensity means A1 plus A2 whole square. I2 is dark band intensity, that is A1 minus A2 whole square, that is equal to 16 by 1. So A1 plus A2 by A1 minus A2 is equal to 4 by 1. So cross multiplication, A1 plus A2 is equal to 4A1 minus 4A2. So 3A1 is equal to 5A2. A1 by A2 is equal to 5 by 3. Ratio of amplitudes, how much they are giving? Giving intensities ratio, that will be equal to 5:3. See the next question. Interference pattern is obtained with two coherent light sources of intensity ratio B. So I1 by I2 is equal to B. Then I maximum by minus I minimum divided by I max plus I minimum, how much? I max minus I minimum divided by I max plus I minimum. This is fringe visibility. How much they are asking. So I max means in terms of I, if we write root I1 plus I2 whole square divided by root I1 minus I2 whole square. I am writing this one in this format. Root I1 by I2 plus 1 whole square. This one root I1 minus I2 minus 1 whole square. Okay. Root I1 by I2 value will be how much? This value will be root B na? Plus 1. This will be root B minus 1 whole squared. No option will be there. Here printing mistake is there. This is for this one, not this one. Okay, root b plus 1 by root b minus 1 whole square. No. It's I max by I minimum. Na? Wait, we did wrong. This is only I max by I minimum. Wait, we did wrong little bit. You write this one in this format. Right? This value will be root p plus 1 whole square by root b minus 1 whole square. This is I maximum by I minimum. Here they are asking I maximum minus I minimum by, so this is I max minus I minimum divided by I max plus I minimum. So this minus this is root b plus 1 whole square minus root b minus 1 whole square divided by root b plus 1 whole square plus root b minus 1 whole square. A plus b whole square minus a minus b whole square means this will be equal to 4ab. 4ab is 2 into a square plus b square. So this value will be 2 root b by b plus 1 at that I maximum. This is the answer for it. 2 root b by b plus 1. Okay. See the next question. Here what they are asking is maximum intensity in the Young's double slit experiment is I naught. Okay. Distance between the two slits is 5 lambda. Here 2 slits is there. This distance value will be 5 lambda. Lambda is the wavelength of the light used. What will be the intensity of the light in front of one of the slits? Your screen is there. Here, what is the intensity? They are asking. So this will be Ona. So this will be how much x by 2. Okay. This is D. Na? D. Then this is D by 2. Wait, we change the symbols. So this will be x. Okay. What they gave here, x is equal to how much here? D by 2. D value they gave 5 lambda. So this value will be 5 lambda by 2. Small d, distance between the two slits. D value they gave it as 5 lambda. Capital D they gave it as 10d. D value 5 lambda, na 10 into D. So this value will be 50 lambda. Okay. Now, so x small d, capital D given. Here, what is the intensity? For finding the intensity, we had to calculate the phase difference. I is equal to 4I naught cos square theta by 2. That is the formula. For finding, we had to find path difference. From that, we will calculate the phase difference. So delta x is equal to x small d by capital D. Here x value will be 5 lambda by 2. This is 5 lambda. This is 50 lambda. 1 lambda will cancel. So finally, this value will be 25 by 100 means lambda by 4. Then find the phase difference. Pi is equal to 2 pi by lambda into delta x. 2 pi by lambda into lambda by 4. This will be lambda by 2. Then find the intensity. I naught cos square pi by 2. This is I naught. How much they gave? Maximum intensity, they gave I naught only. Then you take I naught only. No need to take 4 I naught. Then cos square pi by 4. This value will be equal to I naught by 2. This is the answer. Next. See the next question, what they are asking. Y1 is equal to 2 sine of 100 pi t minus 5 by 3, 5.3x. Y2 is equal to 2 root 2 sine of 100 minus 5.3x plus 5 by 4. See here, sine is there now. So it is going along the x-axis. It is going along, these two waves are going along, this wave, y1, is going along the x-axis. This will be like this. This wave is y2 is going like this, with amplitude 2 root 2. This value will be pi by 4. Here actually, they gave printing mistake here. Here sign is not there. It will be cos. So this y3 is equal to cos pi t minus 5 by 3x. I am converting this as a sine. 100 pi t, no, 5.3 this is. Minus 5.3x plus pi by 2. So it is with pi by 2 angle, it is there with x-axis. This amplitude is 1. What is the net amplitude? I am resolving this into two components. Ax is equal to 2 plus 2 root 2 cos pi by 4. This will be 4. Ay is equal to 1 plus 2 root 2 sin pi by 4. This will be 3. Because root 2, this will cancel, root 2, this will cancel. Then resultant amplitude is equal to square root of ax square plus ay square. This is 4 square plus 3 square. This value will be 5 units. Okay, that will be the answer for this. See the next question, what they are asking. In Young's double slit experiment, the eighth maximum with wavelength lambda1 is at a distance d1 from the central maximum, and the sixth maximum with a wavelength lambda2 at a distance d2. Here missing is there, lie at the same point is at a distance d2. Then d1 by d2 is equal to how much they are asking. Young's double slit experiment, eighth maximum with wavelength. They are not lying at the same point. At a distance d1 from the central maximum, and the sixth maximum with wavelength lambda2 is at a distance d2. Okay, then d1 value will be how much? N lambda capital D by small d. Okay, d2 is equal to how much? 6 lambda 2 capital D by small d. d1 by d2 how much? Capital D, small d's will cancel. 8 lambda 1 by 6 lambda 2. 4 lambda 1 by 3 lambda 2. This is the answer for it. Distance of the nth bright band from the central bright band. What is the formula? Yn is equal to n lambda d by d. Using this formula, we did this one. Next, in YDSE, Young's double slit experiment, separation slits are separated by 0.1 mm, and this will be small d. This will be capital D. This is wavelength of the light used. Distance between 7th maximum and 11th minimum on the screen. So Y1 is equal to 7th maximum 5 lambda capital D by small d. Y2 2n minus 1, 2 into 11 minus 1 lambda d by 2d. Okay, this value will be how much? 21 lambda d by 2d. This is 10.5 lambda d by d, which is more, this is more comparing to this. Therefore, delta y is equal to y2 minus y1. So lambda d by d, if we take a common, 10.5 minus 7, so 3.5 lambda d by small d. 3.5 lambda value 5 into 10 power minus 7. Capital D value 0.5. Small d value 1 into 10 power minus 4. So this will be 10 power minus 3. So multiply this 3.5, this will be 2.5. 5 5s are 25, 15, 17, 2 5s are 10, 7. So this will be 8.75. 8.75 into 10 power minus 3 meter. So this value 8.75 millimeter. Okay. So this is the answer for it. See the next question. Young's double slit experiment, totally 241 fringes are there on the screen. Setup is immersed in the water. How many fringes will be formed? So total number of fringes. Is equal to 2d by lambda plus 1. They gave this is 241. 2d by lambda plus 1. 2d by lambda is equal to 2. In water, number of fringes n dash is equal to 2d by lambda dash plus 1. So 2d by, this is lambda by mu plus 1. 2d mu by lambda plus 1. 2d by lambda will be 240. Mu value 4 by 3 for water plus 1. Right here, mu is equal to 4 by 3. So this value finally 380s will cancel. 84s are 320 plus 1, that is equal to 321. Okay. See the next question. Already this is a repeated question. Already we did this one. No need to do once again. For this answer will be I naught by 2. First we did this question. Next 28. A double slit experiment is performed with light of wavelength 500 nanometer. Lambda value 500 nanometer. Thickness will be 2 micrometer. Refractive index will be 1.5. Shifting the central bright band X is equal to, what is the formula here we will use? Mu minus 1 into P by lambda. 1.5 minus 1. P value 2 into 10 power minus 6. Lambda value 5 into 10 power minus 7. Okay, this is 0.5 into 10 power minus 6. 5 into 10 power minus 1 will cancel. So X is equal to 2. In the path of the upper beam it is placed. So it will shift upwards, not downwards. So this is the answer for it. Shift upwards nearly by 2 fringes. Next. Young's double slit experiment. Nth red band coincides n plus 1th blue band. Wavelengths of red and blue colors are given. Means here what we can write here. N into lambda red is equal to n plus 1 into lambda blue. So n into 7,500. n plus 1 into 5,000. 2,500 2 times, 3 times. 3n is equal to 2n plus 2. N is equal to 2. This is the answer for it. See the next question. When a thin transparent plate of refractive index 1.5 is introduced in one of the refracting interfering becomes 20 fringes shift. It is replaced by another thin plate of half the thickness and a refractive index 1.7. Number of fringes that undergo displacement will be. Shift formula x is equal to mu minus 1 into small t by lambda. Wavelength same only. Here this value will be shift, a number of fringes shift, take it as n. So n1 by n2. Mu1 minus 1 into t1 divided by mu2 minus 1 into t2. And then you substitute the values 20 by n2. This is 1.5 minus 1 into t. 1.7 minus 1 into t by 2. This is 0.5. 2 will go to the numerator. This will be 0.7. So this value 1 by 0.7. Then n2 value is equal to 20 into 0.7. This will be 14. Okay. So this is the answer for it. Next, see the next question. In Young's double slit experiment using monochromatic light of wavelength lambda, path difference corresponding to any point having half of the peak intensity. Intensity formula I is equal to I naught by 2. Okay. Next, this I value will be 4 I naught cos square pi by 2 is equal to I naught by 2. This is only 4, not 4. So I naught will cancel. Cos square pi by 2 is equal to 1 by 2. So cos square cos pi by 2 1 by root 2 cos 45 degrees. Then pi by 2 is equal to pi by 4. Pi is equal to pi by 2. Okay, understanding. Then they are asking what is the path reference we got, phase reference how much. Phase reference we got, path reference how much they are asking. So pi is equal to 2 pi by lambda into delta x. So pi by 2 pi by lambda into delta x. Delta x is equal to lambda by 4. Next, how much will come? Three lambda by 4 will come. Next, how much will come? 5 lambda by 4. So 2n plus 1 into lambda by 4. Okay, so this is the answer for it. See the next question. In Young's double slit experiment, Young's double slit experiment is performed in a light. 10th bright fringe in liquid lies where 6th dark fringe lies in vacuum. Refractive index of the liquid will be approximately how much they are asking. So what is the question? See, 10th bright fringe in liquid. N lambda d by mu d is equal to 2n minus 1 lambda d by 2d. This is distance of the 6th dark band in vacuum. This is the distance of 10th bright band in liquid. Lambda d by d, lambda d by d will cancel. This will be 11 by 2. Then mu is equal to 20 by 11. So this is 1.8. This is the answer for it. Next. What is the question? See, a person sets up Young's experiment using a sodium lamp and placing two slits 1 meter apart, 1 millimeter apart. 1 millimeter from the screen. Slits distance is not 1 meter. The person is not sure of slit separation and he varies the separation and finds that interference fringes disappear if the slits are too far apart. Angular resolution of the eye is 1 by 60 degrees. How far are the slits when the just cannot see the interference pattern? What are the given quantities? C, small d is equal to 1 mm. And theta value will be 1 by 60 degrees. Convert this into radian. 1 by 60 into 5 by 180 radians. Lambda value 5980 into 10 power minus 10 meter. Then small d value, how much? Using this, initially this is the separation. No need to consider this as d. You find d. At some separation, it is not visible. Okay, what is that d you have to find? Initial separation is this one. So here theta is equal to what will happen? Lambda by d. D is equal to lambda by theta. Lambda value 5980 into 10 power minus 10. This value 5 by 60 into 180. If we calculate this one, finally this d value we will get 2.05 into 10 power minus 3 meter, 2.05 millimeter. Okay, so up to this distance we can see the interference pattern. After that we can't see. So this is the answer. Okay, next. Young's double slit experimental setup is completely submerged in the transparent liquid. Which of the following graphs is best represented? The variation of total number of fringes. Here, for example, length of the screen is L. Each fringe width will be beta. How many fringes are appearing? Number of fringes. L by beta. On the screen, how many fringes are formed means L by beta. In water, what will happen? In water or any liquid? In liquid. N dash is equal to L by beta dash. L by beta by mu. L mu by beta. So number of fringes is directly proportional to mu. Okay, graph between them will be a straight line. Here n value, here mu value. It will be a straight line passing through the origin. So this is the answer for it. What is the question? Young's double slit experiment is completely submerged in the water. Then capital N fringes are observed. Then if you draw the graph between refractive index of that liquid and N, what is the shape of the graph they are asking? Graph will be a straight line passing through the origin. Next question, see, this is one wavefront, AB. Here one object is there. Either it may be a slit, either it may be a biprism, either it may be a prism, either it may be a glass plate. Then from this plane wavefront, after passing through this, it came as DE. What is this? Either slit or biprism or prism or glass slab. Slit, what it will give is divergent beam, it will give. Means if this is the slit, output coming from this will be like this. Comparing to this, its size will be more. Actually, it will be like this. Here size is ABDE size is same. So slit is not the answer. Biprism will give two outputs. Here one prism will be there, here one prism will be there. These two will give two outputs for one input. Here only one output is there, so this is also wrong. Biprism, it gives two images. Okay, prism, what it will do is, if this is the incident wavefront, emergent wavefront may be like this. So prism will be the correct answer. Fourth, glass slab. Here one glass slab is there like this. This is incident wavefront. This will be emergent wavefront. Both will be of same direction. So answer will be C for this. Next. Figure shows, actually it will be like this, little bit bigger. Typists don't know what is the meaning of them also. Okay. This wavefront passes through A and it came like this as Q. Q passes through some more B and came as R. What is A and B? So comparing to this, this is convergent beam. So it will be converging lens. A will be converging lens. Here it deflected like it moved like this means it will be prism. Okay. So Q is more convergent than P. So capital A is a convergent lens. Next, R direction of R is different from Q. So B is a prism. One will be convergent lens, another one will be prism. Next, see last question. Wavefront of light is given by this equation x plus 2y plus 3z. This chapter typist did so many printing mistakes. X plus 2y plus 3z is equal to constant. Angle made by the light with y-axis. This is direction cosine. Cos beta is equal to ay by mod a bar. Ay will be 2. This value 1 square plus 2 square plus 3 square 2 by root 14. Okay, tomorrow also we'll do some more questions in this. And today we'll stop this session now. Okay. Okay, we'll start this session.